Hi everyone, today we're going to review statistics. We'll look at histograms, dot plots, box plots, probability distributions, and normal distributions. Get ready to unlock the power of math together. Let's dive right in. So here what we're going to look at is a certain distribution that is approximately normal, and you are given the mean as well as the standard deviation. Now, when you're given these x values, you're going to use in your calculator the normal CDF option. You are trying to find the percent of data that would lie between 20 and 25. So when we do the normal CDF, you're going to put the lower number, the upper number, the mean, as well as the standard deviation. So what we've got is our normal CDF, and our lower number is going to be 20, upper is going to be 25. Our mean is going to be 25, and our standard deviation is going to be 5. Where you go to your calculator is you're going to press the second button and then the VARS button, and the normal CDF option is option number 2. So as we do this, what we will get is 0.3413, and as a percent, our answer would then be letter B. Okay, in this question, Lauren is enrolled in a calculus class. So on the first exam, the class mean was 75 and the standard deviation was 10. On the second exam, the mean was 70 and the standard deviation was 15. And Lauren scored an 85 on both of the exams. So assuming that the scores were approximately normally distributed, on which exam did she score better relative to the rest of the class? We're going to compare the z-score. So remember, the z-score is sort of telling you the direction and the number of standard deviations that this value is from the mean. So to calculate the z-score, we have a formula. It is the value minus the mean over the standard deviation. Okay, so on the first exam, the z-score is the value, so that's 85, minus the mean over the standard deviation, which is 1. And on the second exam, the z-score is value of 85 minus the mean over the standard deviation, which is actually also 1. So, with these two numbers, the z-scores are the same, so Lauren actually scored about equal on both exams and relative to the rest of the class. Okay, here we have our two box plots, and we want to know which of the following statements can not be justified. So let's look at what we have here. We have our range of data set 1, which is 60 minus 20, that gets me 40. And the range for data set 2, also 60 minus 20, which is 40. We know this is good, this is equal. So for letter B, the interquartile range, that is Q3 minus Q1. So for data set 1, that is 45 minus 30, which is 15. And then for data set 2, that is 50 minus 35, which is also 15. So this is good. Let's see. The median for data set 1, so the median for data set 1 is less than the median for 2. So that's 35, and that is less than 45. That is good. Data set 1 and 2 have the same number of data points. We actually cannot tell this, so we're going to think that it is D, but let's just confirm letter E before. Both data sets are skewed. Yes, that's true. 1 is skewed to the right and 2 is skewed to the left, so that's good. So our answer choice is letter D. Okay, so here we are given the data sample of 200 children, we want to find out what the IQR is. So again, that is Q3 minus Q1. So that's 48 minus 43, which is 5. Okay, so here we have Silas and we have ACT scores, and they are approximately normally distributed. Okay, so we're given here mean, we're given standard deviation, we're given the value of 28.3 that he scored on the ACT. So again, when we're given those X values, we're going to use normal CDF. So we're going to put the lower limit, the upper, we have the mean and the standard deviation. So what we know, the upper is we want to figure out again, like here's Silas, here's that bell curve, and it's got about 28.3, right? So we're trying to figure out the lower side of that, right? So we know the lower has to be 0, right? That's the lowest you could get. The upper is going to be Silas's score. We're also then going to put in our mean, which is 20.6, and our standard deviation, which is 5.2. So the answer that we will get is 0.9306, but then changes of percent would be option A. Okay, so here we have concert attendance, normally distributed, got a mean, got a standard deviation. We want to know how many people would need to attend in order to be in the top 2%. Now, here you're given a percentage, right? When you're given a percent, you're going to use the inverse norm. So inverse norm is the area and then mean and standard deviation. So now when we look at the bell curve, right? We got the bell curve. We want to figure out what is the top 2% over here. All right, so that is 0.02. And then you've got this 98%, right? You have the 0.98. All right, so now there are two ways you can do this, and it depends on the calculator that you have. So if you have the 84 CE calculator, you can actually choose the tail, okay? And you are told like left, right, or center. Now we want to figure out this tail. So you, in this case, would choose the right tail, okay? And then you would then continue, right? You would, with your inverse norm, you would have this information. So you are looking at 0.02 because you want that 2%. You're going to put in your mean, which is 25,601, and then your standard deviation, which is 7,641. So that is the first way that you can do it. If you cannot choose the tail, okay, you would do inverse norm again. However, what you're going to put for the area is not going to be the 0.02. It's actually going to be this 0.98, okay, because it is up. After you get this area, then you're going to be given that sort of mark right where that 2% starts. So right after that 98%, you're getting that tail end. I gave that number. You're getting this value right in between those. So now you got 0.98, but still, again, 25,601 and then 7,641. So when you plug this into your calculator, what you will get is about 41,293.69. So when we round up, you're going to get letter B. Okay, so here we have Q1, Q2, Q3 data. Okay, so let's figure out what we got here. We want to know which one's true. Okay, so at least half of the customers spend less than or equal to 44. 27, and then at least half spend greater than 44. So where 44.27 is, Q2, remember, is your median. And the median, remember, is at 50%, right? So that actually works out. That's actually true. Let's make sure that nothing else works. So we got 75% of the customers spend between 36 and 58. Okay? Well, to go from Q1 to Q2 is 25%, right? And then Q2 to Q3 is another 25%. So not 75%, it's actually 50%. So that one's out. All right, so letter C, you got 25% of customers spend less than or equal to 58.9, and then the remaining 75% spent greater than or equal to 58.7. Well, here's 58.7. Okay, well, this is in the upper 75%. So if we're looking at less than, that's actually 75%. That's not 25%. So that one is out. We're going to look at D. The mean amount spent by customers is 44.27. Not the mean, actually the median. The median. So this one's out. And then the majority of customers spent 44.27, but we don't know what majority means. We can't tell. Well, we know the median, but we don't know if that is really the majority. And really with the majority, you really think more than 50%, and that wouldn't be true either. So we can't verify that. So letter A would be our final answer. Okay, here we have a histogram. And for this first question, what we're going to do is we are going to figure out what could be the median in the wait times. So we know there are about 80 patients here. We got 50 patients here, a little bit trickling in. So we know our median is probably going to be somewhere in that interval there. So we can say it's probably going to be about 7.25. All right, here we're going to figure out what the shape is. So we look at the shape. Okay, it is skewed, right? You got that little tail there that's skewed to the right. So that is option B. Okay, here what we have is raffle tickets. We want to figure out what is our expected profit of buying a ticket. So right now, we're going to make a little probability table. Whenever we want to find expected profit, we're multiplying each of our values by the probability and adding up all those results. So let's make a table here. Our X is actually going to be our money. It's like how much we are earning. Okay, so let's figure out what we can do. So we're buying one out of 200 raffle tickets, right? And they're sold for $10. Now, we know that one winner is going to get $1,000. So it's $1,000, but then you bought the ticket for $10. So what you actually earn is $990. And the chance of you getting that, because you bought one ticket, is 1 out of 200. Then you have one winner who will get $100. So if you have $100, but you bought a ticket, how much you will take home for those earnings would be $90. And again, because you bought 1 out of 200 tickets, that's the probability. All right. And let's say you don't win, right? You don't get the $1,000, you don't get the $100. So you don't earn anything. So that's zero. But you spent $10. So you're out $10. And that chance is 198 out of 200. Now, in order, again, to find our expected profit, we're going to take each of our values, right, and multiply them by our probabilities here. And we're going to add up each of these together. And then minus 10, 198 over 200. And what that's going to give us is $4.50 as our expected profit. All right, here you have a ski resort either making money or losing money. So probability, we are given, again, expected profit here. So let's make a little table for ourselves. Okay, so what we want X to be, that's going to be, again, our earnings or our money here. So we have a ski resort that makes $500,000. But then also loses $120,000, so we're negative here. If the probability of having more bad days is 42%, so 0.42, that means that our 500,000 is a 0.58. So we're going to take each value here, multiply it by that probability, and then we're losing 120,000, so 0.42. So expected profit is $239,600. Okay, here we're going to compare. So we're going to look at shape, outliers, center, and spread. So let's go ahead and look at this data. You're given Oscar winners, and the first thing we want to do is we want to figure out the shape. So we want to ask ourselves, is this symmetric or is this skewed? So what you will see is actually these outliers pull that tail, right? They skew your data to the right. So how we will write this is that the distribution of ages of female and male actors is positively skewed or skewed to the right. When we look at our outliers, we're going to ask ourselves, how many are there and where are they? So with our 3 female outliers, it looks like they're at 60, about 73, and 80. And you have 1 male outlier at about 75. Okay, so for center, if your data was symmetric, you're going to talk about the mean. If your data was skewed, you're going to talk about the median. And we're going to use comparative words here. So the median age for females, 32, is lower than the median age of males, which is 42. Now, when we talk about spread, if your data is symmetric, you're going to talk about the standard deviation. If your data is skewed, you're going to talk about the IQR. So because our data is skewed, we're going to talk about the IQR, and we're going to again use comparative words. So the IQR of males, which is 15, is greater than the IQR of females, which is 8. So another thing to remember is if you have one that is skewed and one that is symmetric, so what you're going to do is you're going to treat both as skewed. Okay, so that's something that you do want to remember. Okay, so here we're going to find mean, median, mode, and range, and then decide which one is the largest. So we're going to do mean first. Mean is adding up all of our numbers and dividing them by the number that we have. So you have 104.8 over 13, so that gets you 8.69. You can also plug this in the calculator and get the X bar. You'll get the same answer. For median, what we will need to do is you'll put your numbers in order and figure out what the exact middle is, and that median is 82. When you want to find the mode, it is the one that appears the most often, which is 7.7. And then when you will talk about range, your range is the max minus the min, and that gets you 4.5. So if we decide which one's the largest, that would be our mean. Thanks for learning with me today, unlocking the power of math one problem at a time. Don't forget to like and subscribe for future notifications on Precalc videos. See you in the next lesson.